yes. Sir,
Yes,
sir,
Akbar.
one question. Our
Yes.
CCNA, Cisco ICE, it will be conducted by you, right?
Yes.
Okay, very good.
You're talking about Cisco ICE, right?
Yes, yes.
After this VPN,
Uh,
we'll discuss this, our next implementation, Cisco ICE.
okay, very good, very good.
If you want any other batches recording, so I can share with you because I just finished on one batch.
Oh,
If you need recording, for example, just revise, okay? So I
okay,
can share with you if you need.
okay, sir. Okay.
Okay, let's focus on this get VPN implementation.
Yes,
So
sir.
I told you branch offices they are connected with MPLS cloud. So your
Yes,
focus is not on reachability, your focus is on encryption.
yes,
So get VPN, generally get VPN is not used on internet. Get VPN we are not using on internet. I told you
yes,
MPLS connection is a separate thing. ISP connection is a separate thing. Okay, internet connection. What is the next feature? What is the next benefit? Okay, this is the scenario, but what is the benefit to use get VPN? Why I need to get VPN? Because in get VPN, you can go with a centralized model. You can go with a centralized model. What does centralized model means? Wait. For example, you have branch office A, branch office B, branch office C, and these branch offices they are connected with this MPLS. This is not a simple ISP connection. This is private WAN technology. So if you remember our previous configuration in IPsec, Akbar, in
yes,
IPsec,
sir.
what we can do, we can create session key, phase one tunnel, phase two tunnel. If you are
Yes,
working with crypto map concept, then yes, you need to define your interesting traffic. And if you have
yes,
any tunnel like MGRE, GRE, or DMVPN, then yes, no need to create interesting traffic. You can just create a profile, and profile you can apply on tunnel interface. Remember our these configuration?
yes,
Okay. So now here we have a centralized model. Centralized model means what? If I'm trying to configure VPN on site A and site B, on site A and site B, and yes, we are using crypto map because there is no GRE, MGRE, and DMVPN tunnel here because this is not a simple internet connection, right? So my point is, if I'm trying to configure IPsec, I need to define interesting traffic, and yes, we have a LAN portion, for example, 192.168.10.0/24. This side, this side, for example, we have 192.168.20.0/24. This side 30.0. This side we have 192.168.40.0. So interesting traffic. I need to define interesting traffic here. Interesting traffic in between site A and site B, in between site A to site C, in between site A to site D. So interesting traffic I need to configure on all devices, right?
yes, sir.
And remember VPN configuration, interesting traffic is required, right? I
Yes, yes,
don't want to configure interesting traffic on each branch office. I'm looking for centralized management. Get VPN is giving you option. Get VPN is giving option interesting traffic and transform set you can configure on a centralized device in get VPN on a centralized location. For example, I have one router here, okay? One router here. For example, this is R5. Here I'm trying to configure interesting traffic transform set into the centralized device. Now, when site A and site B, they are trying to communicate with each other. They can download interesting traffic information, transform set information from this centralized router. Clear my point?
yes, sir. It's clear.
So the good thing is what? Branch offices, they don't know about the interesting traffic in VPN configuration. I will show you the configuration. You can get a clear picture. But my point is what? Interesting traffic transform set session key. You can configure in in a centralized router. Into this centralized router is called R5. And this router is called what? Key server. This router is what? Key server.
Feature.
And now these are called group members. For example, site A. This site A is a group member. This site B is a group member. This site group member, group member. So what I'm doing, this is group member one, group member two, group member three, and this is group member four. So when group member they are trying to communicate with each other, they don't have interesting traffic and transform set in VPN configuration. They don't have. They can download these interesting traffic and transform set from a centralized key server. Okay, and key server and group member cannot be configured on same device. So key server is a separate dedicated device. Clear my point?
Yes.
I will show you how to prepare key server. I will show you. So key server is a separate thing. You cannot use a router to act as a key server and group member both. No. Either you can use key server or you can go with a group member. Now let's create a design. Okay, let's create. We don't have MPLS cloud here, but I'm creating a design where I have a reachability. I have a connectivity. Okay, I don't have any problem in connectivity. For example, I have branch offices. Wait. Into this design, this R5 I'm using as a key server, and R1, R3, and R4. These are called group member. So group member one, group member two. This one is group member three. R2, yes, R2 I'm using as a service provider. Now let's configure IP address as per our design. Okay, in between R1 and R2, 12.0 network /24 10.1.15.0 /24 23.0 and 24.0. Let's configure IP address now. We can create a reachability. Akbar, can you hear me here?
Yes, sir. Yes, I can hear.
Okay, so please wait 5 minutes. I'm doing basic configuration and a reachability in between these devices. Let's start our configuration. So this is group member one, host name I'm giving GM1, fast Ethernet 0/0, 10.1.12.1, mask, no shutdown, 0/1, 10.1.15.1, mask, no shutdown. Let's configure any protocol for reachability. Okay, Akbar?
Yes, sir.
Into the design, yes, we don't have MPLS cloud, but my point is what we need reachability. So I'm creating a complete reachability in between these devices. And for reachability, I'm using EIGRP protocol. So my point is all devices are reachable with each other. R2, host name, this is ISP router, interface fast Ethernet 0/0, 10.1.12.2, no shutdown, 0/1 interface 23.1, mask, no shutdown, 1/0, 10.1.24.1, show IP interface brief. Router EIGRP 10.1.12.0 wildcard mask, 12.0 and 23.0 and 34.0. No auto. No, not 34, 24. Let's go to R3. So R3 is group member 2. Host name is GM2. 0/1, 10.1.23.2. No shutdown. Now, okay, let's create a loopback interface. So 192.168.30.1. So for root, I'm creating loopback. 23.0 and 192.168.30.0. This is your LAN network. No auto sum. Let's create a loopback interface on R1 also. So interface loopback 0, 192.168, 10.0, 10.1, router Okay, let's move on. R R5 bit. Where is R5? Yes. Let's configure with the R4. 0/1, 10.1.24.2. Mask, no shutdown. We can create loopback interface 192.168.40.1. Router EIGRP 10, 40.0 wildcard mask, 10.1.24.0 wildcard mask, no auto summary. Let's go to R5. This is our key server. So host name is a key server. Interface fast Ethernet 0/1. 0/1. So 10.1.15.2 mask. router EIGRP 10, 10.1.15.0 wildcard mask, no auto summary. So into this design, we have complete reachable network, Akbar. You can verify connectivity with any interfaces. For example, we have loopback on R3, 192.168.30.1 loopback interface. We have one loopback on R4, 192.168.40.1 slash 24, one loopback on this group member 1, 10.1 slash 24. So now let's verify reachability with any devices. Okay, 192, 10.1. Yes, you have a reachability from R5, from key server. 30.1. Yes, you have a reachability. Then 40.1. Yes, you have reachability. So you have complete reachable network. Akbar, can you hear me?
Yes, sir.
Let's start our configuration. Let's start our configuration with key server. So let's go with the command syntax first. Okay, then we can execute on router. Let's verify first. Remember our phase one configuration.
Yes.
Okay, so phase one configuration step is same. Crypto Isaac MP policy. This is phase one configuration. This is session key. Session key. So we have multiple offices, multiple branch offices. So this session key we are using with any IP address. Now this is what transform set interesting traffic. So I'm configuring interesting traffic into this centralized location. I will not configure on any branch offices, any sites. In key server, I'm defining what interesting traffic transform set. Now, for how to use this router, this R5 as a key server. So here we can create GDOI group. For get VPN, we can create what? GDOI group. What is GDOI group? Group domain of interpretation. Okay, it's a full form of GDOI. Okay. So for get VPN implementation, if I want to use R5 as a key server, I need to create GDOI group. And all the routers, all the branches, they can be joined this GDOI group. Clear my point, Akbar?
Yes, sir.
Clear this point? You
Yes,
can
it's clear.
you can create GDOI group here into this centralized router, into this R5, and your group member one, group member one, group member two, group member three, or you have multiple sites. They all can join to this GDOI group. So let's start our configuration. Okay, we can create G2I group. So let's start our configuration with phase one. This is key server. R5 is a key server. And I'm following this text file. So crypto Isaac MP policy 1 authentication pre-share. Diffie-Hellman group 2 for hashing MD5 for encryption. I'm using triple dash. Now, crypto Isaac EMP key CCIE123 address. So yes, I have multiple branches, so I'm using any. Now transform set crypto IPsec transform set, and transform set I'm using TS ESP triple dash ESP MD5. Now access list. So I'm creating access list into this centralized location. How to create access list? Access list 100 permit. And you can see now into this design, this is our interesting traffic, right? 10 dot network. These are
Yes.
called interesting traffic, Akbar. And
Yes, sir.
into this interesting traffic, you can see 192, 168. These two octet are fixed.
Fixed. Yes.
192, 168. So in our
You
interesting
added.
traffic, yes, in our interesting traffic, I can use 192, 160. I can match these two octet. Now wildcard mask. This is source,
You put
source,
250.
and
Okay.
192.168. This is what? 0.0. 0.0255. So this is our source.
Mm.
Source start with 192.168. Can communicate with destination start with 192.168.
Yeah.
Clear now? So we can
Yes, sir.
configure our interesting traffic. So we are familiar with these commands. Phase one, key, session key configuration, transform set configuration, interesting traffic. Now, now I'm creating profile. Here we can create IPsec profile. What is the use of this profile? This profile I will use in GDOI group configuration. So I'm creating IPsec profile. Into this profile, what I can do, I can call transform set. So crypto IPsec profile is what? Prof1 set transform set in our design, in our configuration is TS. Exit. And now let's configure GDOI group, because this R5 I'm using as a key server. Command syntax is very simple. Crypto, remember crypto command, crypto. So most of the time we are using crypto Isaac EMP, right? Crypto
Yes.
IPsec or crypto Isaac EMP, right?
Yes.
Now here we have an option, what? GDOI policy. So we can create Isaac EMP policy. We can create IPsec policy. Now we are creating a new option. It's called what? GDOI policy. So crypto GDOI, and you can go with the group command. You can give any name here. You can give any name for this group. For example, CCNP. Now here we can use identity number. We can use identity number. And this identity number is required for group members. If they want to join this group, they required same identity number. So I'm using what? Identity number. And you can select a number in between. We have a big size. You can select any number. For example, I'm using 100. So this identity number I will configure on each sites. Akbar, clear my point? To
Yes.
create
Yes.
to create a relation in between group member and key server, we need this identity number. Now server local is a command. This key server we are using as this local server we are using as a key server. Now security association SA IPsec, you can select any number. So I'm creating security association IPsec first, and here into the security association I can call to profile. And what is profile name? We are using
CCNA. You
prof1.
see.
No, prof1. File,
Profile only.
file. Now here we can use what? Match address IPv4. And what is key server IP address? This R5 IP address. So IP address we are using for this key server is what? 10.1.15.2. So here we can define this key server IP 10.1.15. Oh, wait. IPv4. Sorry, here we can match our ACL first. Wait. ACL. So ACL number we are using 100.
100.
Yes. ACL, I think, yes, 100.
100. Yes.
So please match address 100. Then you can type exit command. This next command, we cannot use into this mode. Clear my point? You can just
Yes. Yes.
exit here. You can just exit here. And here you can type what? Address IPv4 and what is key server IP 10.1.15. Done. Our configuration. Key server. Let's go to group member one. Group member one. R1 is a group member one, right? So let's start
Yes.
our configuration for group member. This is command syntax. Let's go to R1. Okay, this is R5. And let's go with the R1. So command syntax, crypto Isaac MP. Let's copy or let's configure. Let's create. Crypto Isaac. Otherwise, we can copy. Wait. Show run. Let's copy this configuration. This can help you. We can edit something, then we can paste. Isaac MP policy phase 1 configuration is correct. And now for group member, this session key, we are exchanging with 10.1.15.2. This is what, Akbar?
Server,
This
key
is key
server.
server IP, okay? So I'm not creating, my point is what? I'm not creating branch offices entry, okay? I'm not creating
Yes,
branch office. This is what? I'm creating my relation only with key server.
key server.
Now, so let's copy this configuration. So we have phase 1, then key information and transform set. No, I'm not configuring transform set. I told you, interesting traffic and transform set. Group members, they can download from key server. Okay. So what I'm
Yes,
doing,
sir.
I'm trying to configure phase 1 tunnel and key only. So let's paste here. Now as a group member, I want to join GDOI group. I want to join. How to join GDOI group? So command syntax is here. Command syntax is here to join GDOI group. So now command syntax crypto GDOI group. You can take any name as a group. So I'm using CCIE. Identity number. Remember our number
Yes.
100 we are using, right? Remember our
Yes.
configuration?
Access list.
No. This is identity
Ah,
number.
yes. Number. There's different number.
Yes.
Yes.
Yes. Identity
Big
number.
number.
If
Yes.
any group member want to join this GDOI group, they require this identity number.
Same number. Yes.
So in our configuration, our design, we are using 100.
Yes, sir.
Now server address IPv4. What is server address? 10.1.15.2. Right? This is key server IP.
Yes.
That's it. And now we are creating crypto map. So crypto map, CMap, CMap, question mark, I'm giving a sequence number 10. And now this time I'm not using IPsec Isaac MP. Akbar.
Yes, sir.
This time I'm creating crypto map, but I'm not creating IPsec Isaac MP crypto map. This time I'm creating GDOI crypto map. This is the command syntax. Now here you can call group. So yes, you have a group. In group, you have all the information. What is group name?
CCI.
CCIE. Set group CCIE. Exit. And now this crypto map we can apply on public facing interface. So this is our 0/0, right? Public facing interface. Fast Ethernet 0/. Wait. Crypto map. And what is crypto map name? CMap. When you press enter, Akbar, when
Yes.
you press enter, you can get a registration message here. Wait, let's paste. Let's press enter. See, start registration, right?
Yes.
Start
With
registration.
15.2.
Start
Key server.
registration. Registration is complete.
Yes. With key
Registration
server.
is complete. Let's go to group member 2. Okay, let's copy this configuration. This configuration can help you. We can copy and we can paste same configuration on group member 2. So yes, we can copy this configuration phase 1 tunnel. Isaac KMP, yes, this is 15.2. This is key server IP. This is key server entry. We can copy and we can paste on. We can paste on group member 2. Done. And now this crypto map, this group, wait, crypto map. Let's copy this crypto map. I think we copy this crypto map, we paste here. Let's apply this crypto map. Fast Ethernet as per design 0/1. So crypto map, and what is crypto map name? C map. Any problem in configuration, Akbar?
No, sir. It's very
This is
simple.
your phase one. This is your key. This is your group. This is your crypto map. And now you can apply your crypto map. Done. So you can see here, there is no any interesting traffic configuration in group member one, in group member two. There's no any transform set configuration, right, Akbar?
Yes, sir. Yes.
Okay, now you can see here group member two. Start registration with key servers, registration complete. Now, if I want to communicate with, okay, let's verify our tunnel first. So this is R1. So R1 and R3 both are registered with key server, right, Akbar?
Yes, sir.
So crypto Isaac MP Shah. So yes, we have a tunnel only with key server.
Yes.
Now, if you go and check on group member two, so group member two, you can verify your phase one tunnel. Show crypto Isaac MP Shah. Yes, you have a tunnel with key server, right?
Yes.
All group members, they had tunnels with key server. Now, show crypto IP6 Shah. Wait, IPsec Shah. So now 0 packet is encrypted, 0 packet is decrypted. Right now, right?
Decrypted.
Now let's initiate our traffic. Before initiate our traffic, let's try to capture so that we can verify ESP header, protocol header now. Let's initiate some traffic. Ping 192.168.30.1 with source 192.168.10.1. We don't have interesting traffic entry in group member 1, in group member 2. If you remember, Akbar,
Yes, sir.
we don't have interesting traffic entry, right? But I'm
Yes.
initiating my traffic. I can communicate. And you can see now. You can see now.
Yes. Yes.
You can see now this is what? Source IP, destination IP. And captured in security payload. ESP protocol you are using. So now you have a complete reachable network. And you have a
Yes.
complete reachable network, and now ESP header is available. It means we have VPN connectivity. You can verify now. Show crypto IPsec SHA. Yes, 10 packets are encrypted, 10 packets are decrypted.
Decrypted. Yes.
Clear this kind of implementation? This is called get VPN, Akbar.
Yes. 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 Clear.
Now we can focus on our next VPN implementation, and this is called VRF await. And now we can focus on VRF aware VPN. Okay, this topic will start tomorrow. Okay,
Okay, sir.
this will take time. This required a complete session.
Yes, because it is very important. I know that.
Every topic is important, Akbar. Okay.
But VRF, something which is little bit difficult to understand.
No. VRF is
No.
simple. See, here we are trying to implement VRF aware VPN. Okay, we are not
Okay.
okay, but VRF is a part of MPLS. It's a simple
Okay.
task. Let me tell you the concept. VRF is nothing. Okay, for example, this is MPLS cloud. This is MPLS cloud, and this is P router. This is P router, and now you have multiple customer. For example, you have a customer ABC company, okay,
Mm.
and you have a customer company is XYZ. So
Mm.
ABC has a two branch A and branch B. ABC company, okay, and
Yes.
XYZ company has a two branch A and branch B. So to connect these two branches, yes, uh, as a service provider, you are providing MPLS connection. So you can
Yes.
connect your customer edge router with PE router, customer edge router with PE router, like this.
Yes.
But the point is, if you remember basic routing concept or router concept, if I have a router, okay, and multiple interfaces are connected directly, I'm talking about directly connected interfaces, okay?
Yes.
So no need to configure any routing. Traffic
Yes.
can go to next interface,
Yes.
right?
Yes.
For directly connected interfaces, no need to configure any routing. So
Yes.
my point is, this customer traffic, this customer traffic can reach to other company customer.
Yes.
Right? That's why service provider can create VRF here. It's a very
Yes.
simple concept, but it is
Yes.
related
Yes.
with routing and switching.
Yes.
VRF concept, MPLS, these are what routing switching technology, routing switching topic.
Yes.
But what our focus is on into this implementation. What is VRF? So in VRF, you can divide your single global routing table into multiple virtual routing table, or you can say it seems like a security concept, security context concept. Remember virtual firewall? We can divide our single firewall box into multiple virtual firewall box.
Yes. 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 We don't.
We have same type of concept. You are dividing your single router into multiple virtual router. So
Yes.
you can create VRF here. For example, you are creating VRF A, you are creating VRF B, okay? And
Mm.
you can assign these VRF to customer. And
Sir, one doubt.
these VRF, they cannot talk to each other.
Okay. Suppose if you want to create two VRF, we need four interfaces on the router, right?
No, see, you can create multiple VRF, no
In
problem.
one
But
single
you have
interface,
to assign on interface.
we can create multiple VRF on single interface.
See, no, you cannot apply. You can apply
Ah,
only one VRF. But my point is you
okay.
can create multiple VRF, but you can apply only one VRF, okay? For example, this is fast
Okay.
Ethernet 0/0. So you can apply this VRF A onto this interface. This
Okay.
is fast Ethernet 0/2. So you can apply this VRF to 0 slash. Clear now my point?
Okay, sir. Okay, clear, clear. Okay, sir.
Okay. So our
Yes,
focus
sir.
is what? Our focus is what? How to create VPN in VRF scenario. Okay. This is our topic. Let's discuss tomorrow. Okay.
Tomorrow. Okay, sir.
Okay, Akbar. Bye,
Okay, sir.
dear.
Sir,
Tomorrow,
if anything changes for timing, please let me get updated by evening. Okay.
tomorrow, if you are free, then we can do our session at 8 a.m. morning.
Sorry, sir.
Otherwise on same time.
What time?
Same time we can do
Okay,
our
same day. Okay, okay,
at
sir. Okay,
9 a.m.
same day.
Okay.
Okay, thank you,
Please,
thank you.
please take videos on your side.
Okay, sir.
Okay. Bye, dear. Take care.